back. In the last video, we configured OSPF in a single area and looked at how neighborships form. In this video, we're building a multi-area OSPF design from scratch. We'll add in an area, we're going to call it Area 1, which will also create an ABR, or an area border router, and we will convert Area 1 into a stub, totally stubby area, and even an NSSA, all live. Well, live because you guys are watching this on demand, but I'm doing it here. We are using the same topology as before. R1 is an iOS XE device, R2 is a Juniper device, and Switch 01 is an NXOS device. Let's jump into it. All right, let's add GE001 to Area 1 on the Juniper device. So we're going to go into config mode. We're going to set protocols OSPF area, the dotted decimal of the area, and then interface GE-001. We're not going to commit this. We're going to wait till we configure switch 1 because we want to look at a few things. This is a point-to-point link, but I'm not configuring the interfaces as point-to-point interfaces. I want to show you guys exactly what happens on a broadcast medium, how the DR gets elected, how the BDR gets elected, and how that is shown in the show IP OSPF neighbors. So in NXOS, everything is a feature, and we have to enable feature OSPF in order to start configuring OSPF. So feature OSPF, and then this is where it's very similar. Router OSPF1. We're going to do a router ID of 33333. Now to configure the actual neighbors, we don't do it under the OSPF process. We actually do it under the interface. So we're going to interface Ethernet 1.1, IP router OSPF1, area 1. We're also going to configure the loopback interface. So loopback 0, IP router OSPF1, area. Now we can specify the number like we did for Ethernet 1.1, or we can do the dotted decimal format of the area. We're going to get out of that. Let's get ready for show IP OSPF neighbor. We're going to commit this. Now when we come here and we start aggressively doing it, we see it's in a NIT and it's a druther, which means it doesn't know who the DR or BDR is at this point. We transition to two-way, so it's starting to exchange information. Now it's an XStart, where it's exchanging data between each other. And then pretty soon, this is going to transition into full, and it's going to tell us what the neighbor's status is on the broadcast network. Now it's exchanging. He's perfect. So what it is now it's in a full state, and the neighbor is a DR. We can validate this on router 2 the same way. We can do show OSPF neighbors, right? We see they're both full. Let's look at the actual neighbor. The detail of that neighbor. And we see the DR is .1, which is router 2, and the BDR is .2, which is switch 01. And we can see that here. If we actually look at the detail of this, we see the same thing. The DR is .1, which is router 2, which that's shown here, that the neighbor is the DR, and the BDR is him, which is .2. Now on R2, let's verify the ABR role. And we can do that with show OSPF overview. Now we see that this particular device has two areas, so area 0 and area 1. They're not stubs. They both have one neighbor up. It gives you the total SPFs that have been run. But if we go up a little bit more, we can see that the area border router is configured. Or sorry, router 2 is the area border router. Now, before we go any further, let's talk about an ABR, or an area border router is. An OSPF ABR is a router that sits in between two OSPF areas. Usually one of them is in area 0 and connects the areas together. Think of this as a translator and a traffic cop that summarizes and passes routing information between areas in OSPF, so OSPF can scale without getting noisy. Now, that's important because if every router was in area 0, anytime there was a SPF recalculation, router CPU would start to go up depending on how big that area is, and you can actually start to have routers dropping packets when that happens. By separating OSPF into different areas, you allow that blast radius to actually shrink rather than affect your network. Let's jump right back in, and now let's make R1 a stub. So stub areas allow type 1, type 2, block type 5, and use type 3 for summaries, for LSA type 3 summaries, plus a default route. To do that, we are going to go back into config mode on the Juniper, and we're going to go set protocols OSPF area 0001 stub. Now you have to add a default metric, but I'm not going to do that so we can see what happens on switch 1 when that doesn't happen. And as you can see, I kind of glanced over this, but we got this particular view into the OSPF network in 0.08 milliseconds. Thumbs up for that. All right. Oops. So let's look at the database real quick before we start messing with some stuff. So we see the database has LSA type 1 router, LSA type 2 network, and LSA type 3 summary. We look at the routing table, specifically for OSPF, we see everything is an inter-area route. So everything is transitioning from area 0 to area 1. Now to configure switch 1 as a stub, that's actually under OSPF configuration, and it's area 1 stub. Now I said that the stub network originates a default route from the ABR. If we look at the OSPF database, we don't see a default route. The default route would show up as a link ID of 0.0.0.0. Maybe it's taken a minute to update the link state database. Let's look at the routing table and see if there's anything there. There's nothing. There is no routes in the routing table at all. Why? Because you need to have a metric set on anything you do with stub type networks. So whether it be a stub, a totally stubby area, or an NSSA, there has to be some type of default metric that's defined so it knows how to tag the default route and the inter-area routes. So we're going to do a default metric of 100. We're going to commit this again. We're going to come back over to switch 1. Okay, he's a stub. Let's make sure there's no erroneous config on here. Show configuration, display, set. Stub. There we go. Took a second. So we see that the regular inter-area routes have their default metrics, but because we set the default metric of 100 for the default route, we can see that the default route is now coming in with a metric of 140. if we actually change that and say we do 250, that means that this default route will now have a metric of 290. So if we commit it, lost my mouse, do it again, now we see that he has a default metric of 290. So now let's talk about, before we do that, let's look at the OSPF database. Now we see we have some inter-area routes and a summary default route, which is exactly what we were looking for. So now let's talk about totally stubby areas, which only allow router links, LSA type 1, network links, LSA type 2, and blocks type 3, type 4, and type 5, and relies entirely on a default route. So to do that, we are going to delete protocols OSPF. We're going to remove the stub, and then we're going to set protocol OSPF in area 1, stub no summary, default metric, and we're going to do this as a 5 so we can see how different it looks over this way. We're going to go into config mode, router OSPF 1, no router, no area 1, stub, area 1, stub, no summary. And we're going to commit this. Look at the OSPF routing table. It's going to take a second because we are jolting the system into removing routes and re-adding routes. So we see it's in the OSPF database now. So we have the type 1, type 2, and the summary. And now it's in the routing table with a default metric of 45. So it would have came in with a metric of 40, but because we have default metric of 5, it's going to add 5 to it. Now, what does this look like on router 1? We're blocking all these LSAs. How does router 1 see 3.3.3.3? So we look at the OSPF routes, we see that 3 is actually an inter-area route, or an IA route, meaning it's going from one area to another area. And that's exactly what we want to see. So now we can actually ping either way. So if I want to ping 333 from loopback 0, I'm able to ping it. If I want to ping it from loopback 1, I can also ping it. And the reverse is true. If I wanted to ping, not pint, that's later, ping 00003 from the source interface of loopback 0, we can see it goes through with no problems. Now finally, the NSSA, or the not so stubby area, allows type 1 and type 2, type 7 for external routes inside of the NSSA instead of type 5. When it leaves the ABR, it translates that type 7 into a type 5 in the other areas. So to show this, I'm going to configure a static route on switch 1. On Nexus, it's a little interesting in how you have to advertise that route into OSPF. So we're going to learn about prefix lists and route maps and all this other cool stuff too. So before we actually configure the NSSA, let's configure the default route. Let's configure that static route. So we're going to IP route 192.168.250/24. And we want to put that into null 0, right? We just want a easy static null route. Now we need to create a prefix list that's going to match on that route. You don't have to do a prefix list. I prefer prefix lists because it's just what I'm used to. So it's IP prefix list and a name. So I generally name my prefix lists exactly what they're doing. So this is a prefix list, that's going to take a static route, put it into OSPF, and I always preface it with PL, and you'll see why I do that in a second. I want to permit 192.168.250.0.24. I want to create a route map that I'm going to call static to OSPF, which would have been very similar to the name of that prefix list if I didn't preface PL, and I'm going to do RM. Permit 10. I want to match on that prefix list. Now, I didn't have to create the prefix list. I actually could match on a whole sorts of things, right? As you can see here, I can match on route type, source protocol, IP features, anything I want, interfaces, right? So if I looked at source protocol, I could match on an instance name. There's so much that you can match on in this. Now, when you're redistributing into OSPF, you also need to set a metric. So I want to set the metric, and we'll do 299. Actually, we'll do 300 so we can see exactly what's going on. I'm going to route OSPF 1, and we're going to redistribute static route map. Static to OSPF route map. Perfect. So now if we do show IP route static, we'll see he's there. You show IP route OSPF. He's not here because of how they're configured. So let's remove those stubs real quick, and we'll see exactly what this is going to look like. I'm on the wrong router. That's why we're not seeing it. All right. Oops. Logged out. Let's remove the NSSA. Let's remove the stubby. So we're going to go into global config, router OSPF 1, and then we're going to go area 1, no, area 1, stub no summary. Let's look at the OSPF database real quick. It's going to take a minute for that to clear out, because we need those LSAs to time out. And we're going to delete protocols, OSPF area. We're going to commit that, turn them back into regular OSPF areas. All right, so we're having an issue with this being advertised. So let's see what's going on. All right. Don't know why there's two of them in here. So we'll do no IP prefix list, OSPF 2 static PL. And we'll look at show route map. It's probably going to be another one. Yep. Then we'll do no route map. OSPF to static route map. So now there should only be one route map. One prefix list, 192.168.250.0. And then we're going to show run begin router.ospf.1. That's going to bring us to the top, get through all this. Why is that stub still there? Router F1, no. Area 0001 stub. Static to, let's see, show, make sure I spelt that right. Easiest way for me to do that is to show run and then paste that in. Make sure I see that. And then let's go to the prefix list. Sorry, go to the route map. Make sure I spelt the route map right. We'll do show run, include static to OSPF prefix list, match 5, permit, perfect. So that's the way it should be. And there is still a stub configuration on here. We're going to delete that. We're going to commit that. There's nothing in the OSPF routing table right now because there was a miscommunication of stuff. Why is it still? We need to get rid of that. We're still not seeing. There we go. That's what happens when you have an area that is bipolar and doesn't know what mode it's supposed to be in. So now we can go back to the NSSA. So if we look at routing tables everywhere, we'll see what we're supposed to see. If we look at the OSPF database, we'll see that now there's a type 5 external link here. And if we go to router 1, we'll see he's an E2 in router 1. Show route, protocols, OSPF. We'll see he also, which we can't see that here, but we see the metric. If we want to dig deeper into the destination is, I believe, is when we will see that he's a type 2 external route. So let's get him in there. There we go. So if we look at the detail, OSPF, the preference is there. AS path is I for internal. We will see that in the database. Show IP, show OSPF database. We see he's an external route in there, and we can pull that up. Look at external, and then look at detail, and then we'll see more information about that external route. So it doesn't paint it specifically in the routing table. You actually have to go into the OSPF database to figure out the type of route that it is, or the type of OSPF route that it is. So now let's switch these guys to NSSA. So we're going to configure here. We're going to set protocols, OSPF area 0001, NSSA. Same thing. All right, so that's good. We're going to commit that. Route OSPF 1, Area 1, and SSA. All right, so let's see what we got here. Show IP OSP, show OSPF database. You see he's external. We're missing a type 7 route. So if we go to here, show IP OSPF database, we have a type 7 external. Took a second. There's the NSSA. So we see him twice. We see him as a NSSA and we see him as an external because he is an ABR. So the ABR will see it in two different places. The reason why you see it twice is because he hasn't aged out yet. So if we go back into it again, sooner or later you see how this bottom guy has a higher age, and sooner or later that bottom one is going to age out. And if we come here and look at it, we see that it's an E2 route. Now we could also influence the type of route that it is on switch 1 inside of the route map. So in that route map, let's say we want this to be a E1 route for whatever reason. It's more than likely going to be the order of preference in how that route is picked. Typically, I just leave my stuff as E2 and I really don't play around with all that. But if you so chose to want to play with that, we can do set metric type to type 1. And if you want to see what is actually in here, so this is for ISIS, this is for BGP, this is for an OSPF type 1, OSPF type 2. So we changed it to OSPF type 1. We look at show IP route OSPF, he changes on R1, R2, database doesn't change much at all. If we wanted to look at the external database, right, this is where we'd see in here, right, he's a type 1. That's how we know he's the old one. So here's the type 1 that's being advertised out. If we wanted to look at what the NSSA looked like, right, you know, type 1, this is the forward router. There's no tag, could tag it if I wanted to. And that's how it shows up in the other routing table in R1 that is actually in area 0 outside of the NSSA network. Multi-area OSPF isn't about passing exams. It's about building networks that survive growth and can scale. If this helped you think like an architect, hit that like and subscribe button and tell me the messiest OSPF design you've inherited or deployed yourself. Thanks for watching and go crush the rest of your day.